Pardon me? Question was
Why do planes fly at 35,000 feet?
very good. So basically, at that altitudes, the drag forces over the aeroplanes will be lesser. Okay, so that's why they prefer at such an altitudes where this kind of disturbances will not be there for an aircraft, and for the signal strength for the communications also will be good.
Sir, I have a doubt too.
Okay.
Okay. I had seen this video once where NASA, they said
Okay.
use the 747 to lift a
Okay.
space shuttle into space. Is it possible, sir?
Question one more time, please. Question was
Okay, NASA once used a Boeing 747 to
okay.
put a space
Okay.
shuttle into orbit. Can
Okay.
that be done?
See, air breathing, you know, air breathing engine cannot go till the outer space. Okay, it can fly up to the limit of atmosphere availability. Okay, for example, Boeing aircraft generally they used as a carrier for supersonic vehicles. Okay,
Okay. But
so up to the limitation of atmosphere only, it cannot cross beyond the atmosphere.
but more,
So,
but it is possible, right?
what is that?
It can lift a space shuttle, right?
Yes, it can lift. Yes, it can lift. I will tell you, even my next presentation, next slides, no, that discussion will come, how it can help for the purpose.
Okay.
Yeah.
Sir, sir,
Yes.
sir, what are the minimum requirements for a stealth aircraft, sir?
Very good question. That is also there in my presentation. I will cover that.
Sir,
Okay.
excuse me, sir.
Yeah, please.
So when India can create geosynchronous launch vehicles, why can't India create twin engine aircraft, fighter aircraft?
India is already developed. No? You might have heard
AMC.
the AMCA, yes,
Yes,
Tejas
sir.
aircraft.
But
Yes.
AMCA is probably coming into Air Force in 2030, sir.
Okay.
During that time, the world will have 6 or 7 generation aircraft, sir.
Yes.
So India may lag behind.
Yes.
So can we create a twin engine aircraft as soon as possible when we can create geosynchronous launch vehicles?
Yeah. See, that's true. Actually, we have the capacity to do that. But the thing is, when it comes to the air breathing engines development, actually, it has some more risks involved. Okay. So, a spacecraft and a satellite launching vehicle and a human being flying aircraft. Okay. These kind of categories will have different protocols. So
Yes, sir.
with all these protocols in mind, our people, our scientists are developing the technology with utmost care. So that's why, and that too, most of the technologies are they are trying to make it indigenous thing. Okay,
Yes, sir.
for for example,
Does it say that we are not performing much of R&D activities?
not exactly R&D activities. Our people are doing it. Okay, but uh, but
Yes, sir.
but only thing is the standards.
Yes,
The
sir.
standards required for getting certification. See,
Yes.
by the time if I spend 1 year or 2 years to develop one technology, then again I go for a certification. The certification process requires some hours of duration of testing. Okay. So,
Yes,
so
sir.
by the time I finish up, hello.
Mr. Venu,
So yes, please.
you can
Yeah.
carry on. Okay, it's now working everywhere, both the places.
Okay, okay. So
Uh,
now shall I proceed from here? Before proceeding
you
that,
can just go 2 slides back and then you can proceed, I think, because they're having some problem, maybe. That's it. Thank you and
okay.
sorry for this trouble.
It's okay, it's okay.
ये वेबएक्स की मीटिंग बंद कर दो तूने करा गया है उत्तम जी हेलो
Hello, Miss Sarpita. Okay, so I am proceeding with the presentation. Before that, I will complete my answer to him that yes, India can develop twin engine, or they are into that AMCA project and LCA Tejas. Very soon, I hope we can show the world that India is capable of doing that. Okay, so let us come back to our roadmap for our friends who missed the presentation. Okay, so as I said, it's our journey. So our roadmap goes with the basics of aeroplanes, then some general topics about the GTS and some questions, some assignments kind of thing I will give you during this my talk. Okay. Then after that, let us exchange our ideas. What is success and what should be the strategy for us to achieve the success and what is its meaning for us. Okay. So all those things we will discuss during our journey. Okay. And I said to friends, please keep watching the aircraft which is presented in the slides. Okay. So again, let me briefly introduce you an aeroplane with different parts. Okay, cockpit where the pilot sits and who drives it. Then engine is basically the propelling device which takes our aeroplane with its attitude forward, backward, rolling, pitching kind of thing. Wing is basically okay. That I will ask you the question. Okay, and the rudder for horizontal movement, sideways movement, and ailerons for the lift and that purposes. Okay, and I said earlier, the Bernoulli's principle is what actually working to lift the aeroplane. That means the pressure difference across the wing is what lifting the aeroplane. Okay. So as I mentioned earlier, there are four forces which are acting on an aeroplane. One is thrust, then lift, drag, and weight. Okay. So thrust is basically to push forward the aeroplane, and lift is basically for the lifting high so that aeroplane can fly. Drag is due to the air resistance on a body in the air, and weight is the gravitational pulling of the mass. Okay, so these are the four forces which are acting on an aeroplane, and it is our managerial skills to cancel one some forces and take the aircraft ahead. Okay, so here if you see this picture, again something happened to the presentation. Someone has shared the screen. Atharva Shankar has shared a screen, I think.
Students, please don't share your screen. Okay, we don't even allow interactive sessions, but since Mr. Venu is wanting to have interactive sessions, then you can keep your mic on. Okay, and when you raise your hand and you can speak, but please don't share the screens. Thank you.
Okay, so the corner screen, okay, the corner, the right side corner picture shows these lines. These lines are nothing but the air particles which are moving over the wing. That shows the air movement. And if you see the upper portion of the wing, see the particle which is following the top portion of the wing, actually they are moving faster than the air particles which are going below the wing. Because of which, because of high velocity over the wing, what happens is there will be a low pressure creation. Because of which, what happens? The air which is present below the wing try to push all the air above the wing. So in between wing is there. So what it does? It will just push the even wing also upwards, and that's how the lift is created. Okay. So this is the basic working principle. And so, but the thing is, we are talking about the force, thrust, and all. So, what exactly the force is? Force is nothing but the difference of pressure multiplied by the cross-sectional area, surface area available for the purpose. Okay. So here some numbers are there, some equations are there. I'm not going to details. I'm not going to details of this equation for you because that's not required for you. But what I wanted here with this slide is we should understand how the force is generated by, I mean, for an object. Okay. So basically the object surface area and the difference of pressure across the body is what required to generate the force. Okay. So now let us see some beautiful pictures. Okay. So now here you see different kinds of aeroplanes. Okay. One is turboprop engine aircraft. Okay. I'm classifying the aircraft based on the engine. Okay. Because these are the main forces. Okay. Turbofan engine, turbojet engine, and turbo shaft engine. Okay. So uh, now having seen these kind of aircrafts, you people might have noticed right in the in the sky probably. Okay, if not in the sky, in the airports, if people have accessed it, have you a lot of different what is different kinds of engines kind of thing? Anybody? Miss Arya, you might have visited, right? So you know. Okay, let me proceed further. I will ask you the questions later. Okay, now if you see the engine names, whichever I told you in the previous slide, turbojet, turbofan, turboprop, turboshaft. These are the four different things. Turboshaft is basically for helicopters. Whatever the helicopters engines are there, they are called turboshaft. Okay. So the basic principle for an engine is simple. First thing is suck the air from the atmosphere, compress it. That means increase the pressure. Then allow the high pressurized air into the combustion chamber and inject the fuel, burn it, then allow it to go through the nozzle to get the required thrust. So this is the basic principle. Okay. But the thing is the application is different. Where are we using? How are we using? How we are going to connect it the rotating motion. So that's where the technique comes. So here comes, I have given you the definition for only 4 types, but here one more thing is there. If you can see the cursor, ramjet engine or scramjet engine. Okay. So here in this picture, you can compare. See, the left to right is what air is moving. Okay. So the aircraft will move from right to left. See here, it is the cold portion. That means temperature is whatever the ambient temperature, and here is the hot zone where the temperature is raised. Okay. So the air is moving from left to right. Here the intake and compressors are the compressors. Okay. So here the pressure, air pressure is being increased by compressing it. Then here the combustion chamber, wherever the petrol or fuel we call. Okay. That's being injected and it's being burnt. Then here is a turbine. Okay. Some from where the air is expanded and through nozzle we will get the required mass. So now what is the scramjet? Have anybody heard scramjet?
Yes, sir.
Yes,
Very
sir.
good.
I have heard, sir. Scramjet and ramjet are two types of jets. But sir,
Very,
Scram.
the scramjet is basically the supersonic ramjet, and the ramjet is normal ramjet.
very good. Very good. So ramjet is basically is that air is entering into the engine with a ramming effect. Ramming means impact. Okay. Okay.
ನಾನು ಕರೆಕ್ಟಾಗಿ ಹೋಗಿದ್ದೆ ಅಮ್ಮ ಆಡ್ ನೆಟ್ವರ್ಕ್ ಬದಲು ಟಿಪಿ ಲಿಂಕ್
Prajwal,
Sir, kindly repeat once, please.
just a minute. Prajwal, mic.
Yes, sir.
Prajwal, please mute your mic. Prajwal, please mute your mic. Okay. So in ramjet, what happens is, unlike conventional engines, the air is allowed to enter into the engine with the ramming effect. Ramming effect means with impact, some force. Okay. And because of which, what happens is, the velocity in the intake itself, the velocity is higher velocity. In case of scramjets, it will be supersonic combustion ramjet. That means the combustion is taking place in supersonic velocity. Supersonic, what is supersonic? It is basically higher velocity than sound.
Sound.
Very good. So, so conventional thing is the air velocity will be whatever the flight velocity, for example. But here what happens is, the air velocity will be higher velocity. Here ambient velocity. Here higher velocity than ambient. So that's how, with the ramming effect, the air will enter into the combustion chamber, and from there the combustion takes place, and the rest of the activities are same. So now, Miss. Now the question has come, no? Miss Rosalie or somebody asked the question: the Boeing aircraft, how it can carry? I mean, what it has to carry, kind of thing, right?
Plane to crash on land or water.
What is that, Sneha? What?
Better for a plane to crash on land or a water.
Yeah, it can. It can land on water surfaces. Okay. There are see, in emergencies, aircraft can land in water. Okay.
Is it
And
better now?
you mean to say, is it better?
Yeah.
See, there are some aircrafts, amphibious aircrafts designed for landing in water also, but normal aircrafts need not land in water. Why it should land in water? When it is better runways are there, beautiful runways are there, why it should land in water? Okay. So,
Emergency.
Sir,
yes,
sir,
please. Yes, please.
you know that, sir, hypersonic is more than supersonic, means it has more speed than supersonic. So sir,
Exactly.
that scramjets are exist. So sir, hypersonic ramjets doesn't exist.
I'm coming to that point. I'm coming to that point now. Anyway, you initiated. I'm going to continue from there. Hypersonics is basically for the velocities which are higher than 5 times higher than the sound velocity. They are classified as hypersonics. Okay. Supersonics is beyond one. It is just higher than the sound velocity. Okay. So hypersonic velocity, for example, NASA's X series experiments, they flew around Mach 10. We call is Mach number. Okay, Mach number is nothing but the velocity of light in compared to the velocity of sound. Okay. Hey, before that, I just wanted to ask you the question: what is the velocity of sound?
340 meter per second in air.
Okay. What is the velocity of light? Speed of light?
Right, 3 into 10 to the power 8 meter per second in vacuum.
Okay. Good. Shall I say 3 lakh kilometers per second?
Yes,
Can
sir,
I
you
say?
can.
Okay. Now one more question for you. What is the speed of time?
Speed of time. Sir, 1 second. 1 second per second.
Okay. You can answer me end of this presentation. Okay. Remember this question. Answer me end of this presentation. I'm going to give you some explanation on that. Okay. So now coming to this presentation. So the ramjets basically required the additional push. So as our friend asked us, the Boeing aircraft, which needs to be carried for the launch vehicles or supersonic vehicles, so that these ramjets or scramjets needed to start the engine itself, they need additional velocity. That's why it cannot be started on the ground. That's why some other aircraft which will take these engines up to the near to sonic velocity or supersonic velocity, then these engines can be structured and separated from the mother aircraft. Okay, I think I have answered. Okay, so now, okay, not too much of technical content, right? So let us see some general questions, general topics to discuss. Okay, so what is the meaning of jigyasa?
Curiosity.
Very good. Anybody else?
Desire to know, to acquire something new.
Okay, good. So it is the curiosity, right? So does it require for us? Yes, very good. So now the thing is how it is going to help. Yeah, tell me, Rosalie.
Curiosity is the major requirement for to invent something, sir.
Very good. So now I'm going to ask you the question. Have you any time thought of what are we learning throughout our life? Have you thought of this kind of tricky question? What are we learning? Are we in right path? Is this useful or kind of?
Aeroplane first.
Hello?
The forces of aeroplanes.
Hello? Okay. So now the thing is these kind of tricky questions should be there in our mind, right? So that we will learn. The curiosity will drive us further to learn the things. Okay. So
Did aeroplane first?
who is that? Who is asking some questions? Someone is asking some question. Tell me, Arya. Okay, so now the thing is the curiosity we talked about. So with that, we will be driven to learn something, right? So with that, what happens is we should have some definite goal, right? To achieve something. So,
Yes, sir.
yes, very good. So we should have some definite goal. So when you have a definite goal, what else you need? You need to plan a strategy for the success. How to achieve that? How to reach that goal? So you should plan it. But the thing is, to plan that, you should have the capability to think differently, to think out of the box. So, along with the logical thinking, you should have the lateral thinking also. ओके सो मैं क्या बोल रहा हूँ अभी एक हमारे स्टूडेंट ने रिक्वेस्ट किया कि हिंदी में भी थोड़ा एक्सप्लेन करो बोल के तो अभी मैं हिंदी में भी बोलता हूँ थोड़ा मतलब आई विल रिपीट इन बोथ द लैंग्वेजेस ओके तो हमें लाइफ में कुछ सक्सेस पाने के लिए हमें डेफिनेट गोल चाहिए ओके और उसके लिए एक प्लान बनाना पड़ेगा तो उसको एक स्ट्रैटेजिकली अप्लाई करके इम्प्लीमेंट भी करना है तो ये सब करने के लिए हमें लैटरल थिंकिंग की जरूरत पड़ेगी लैटरल थिंकिंग के मतलब थिंकिंग का मतलब क्या लैटरल थिंकिंग का मतलब है मतलब हमारे दोस्तों से कुछ अलग से तरीके से सोचना यू हैव टू थिंक डिफरेंटली सो अभी मैं आपको एक एक्सरसाइज देने वाला हूँ अभी इधर जो एक वाटर प्यूरिफायर दिख रहा है आई थिंक यू पीपल आर हैविंग सच काइंड ऑफ वाटर प्यूर्स homes, right? Now I want you people to answer for this question, okay? Okay, अभी मैं ये क्वेश्चन पूछने वाला हूँ कि ऐसे वाटर प्यूरिफायर में समझना कि ये टैप से वाटर निकल रहा है ठीक है टैप इज ओपन बिना इसको टच करके इसको बंद करना है आपके पास एक बॉटल भी है ठीक है आप इसको पानी को कैसे रोकते हैं so here what I'm telling is the tap is open water is dripping here okay water is flowing now you have a bottle in your hand without touching the tap, you have to stop the water flowing. How can you do that? Anybody can answer.
Sir, the tap means
The bottle under the tap.
Princely, you can answer. Princely, you can answer. You have raised the hand. You can answer.
sir, the tap means the upper part means the sir tap मतलब सर वो लीड होगा कि मतलब पूरा टैप मतलब बिना टैप को
पूरा
छू के.
हाँ बिना अभी टैप ओपन कंडीशन में है, पानी गिर रहे हैं, ठीक है, टैप को अभी छूना मत, सिर्फ बॉटल को यूज करना एंड पानी को स्टॉप करना. कैसे करोगे?
Something to do with air pressure, sir?
You can tell me. You can give your idea. Okay, you give your idea. Whether it is wrong or right, it's immaterial. You can tell me your idea. How you now? I want to analyze how you are going to think laterally. Okay, how you are different.
With the bottle.
Okay, with the bottle only. You have to use the bottle only.
Sir, can we means invert the filter?
Okay,
So the water that is present in the filter will go to the bottom side, and in that bottom side means in the previously in that case it was upright, means in the bottom in the upper part suppose it has some gap. So when we will invert it in the bottom part, the gap will be filled by that water. So the tap will be access to water, so it will stop.
Okay, good. But the thing is, here you are not supposed to touch anything else other than only bottle.
Okay.
I'm getting beautiful answers. You know, somebody is telling switch off the water purifier. Somebody is telling use some sensors. Somebody is telling collect the water full in bottle. I'm telling you small bottle. Okay, small bottle which can fit the only
Sir?
this one tap diameter of the tap. Yes, tell me please.
Okay, so how about a system where we have a laser sensor? You know, water and air have slightly different refractive indices, so
Okay.
it bends, right? So when the sensor sees that the laser is bent a little, sensor
Okay.
will turn off immediately.
Okay, good, but it's a lengthy process. Anybody else? I got one answer from Rajveer. Okay, I will tell about that answer later. Meanwhile, if anybody can answer, you can tell. I got the correct answer from Rajveer. So I'm telling the answer. Okay. See, the bottle can be pressed to the tap. Okay. So because of which what happens, whatever the volume of air is there, that will be replaced with little bit of water. But after that, the vacuum will be created in the bottle, because of which it will become like airtight thing, and nothing can enter into that vacuum chamber, and water flow will be automatically stopped. So first of all, let us applause Mr. Rajveer, who has given this answer. Okay, very good. So that's what I'm saying is here. These kind of things they are in our daily routine thing. You can try this exercise. Okay, you can try with a small bottle like 10-20 rupees Coke bottle. You can try this because that mouth will fit into that. Okay, so now let us see for the success, what are the qualities that you should have? Okay, this actually there is no standard scale for you. Okay, the qualities apart from regular qualities like doing hard work, doing, you should have sincerity in defining your goals, then implementation. Other than that, you should define your own qualities. That should again, that will lay the path for the next generation. Okay, then you must dream and you must enjoy the journey of success. Okay, these things definitely will help us in becoming successful. Okay, so now let us see some examples who those people know, some great thinkers. They have laid the path for us how to think differently and how they have achieved the success. Okay, so have have you any time come across this name?
Yes, sir.
Very good. Who is he? Can you tell me?
He was a mathematician. He derived a method for finding prime numbers minus between 0 and 100, 0 and 200, etc.
Okay. Okay. The Eratosthenes is the guy, okay, who actually first defined the radius of our planet. Okay. So how he found the diameter of the earth. Okay. It's a basic simple thing that by reading the shadow of one stick, okay, he has measured it. For example, for the purpose, he traveled from Siam to Alexandria. Okay. So just see his time. It's 276 BC to 194 BC. Okay. During that period, what kind of gadgets he is having? But see his curiosity to find out, his interest to find out the diameter of the planet in which he is living. Okay. So that curiosity drove him to travel from Siam to Alexandria. You can check in Google how far it is. Okay. And those days he traveled and he used the parallel sun rays to find out the angles, and from there he found out the distance. So here I'm not going to tell you the what kind of method he did it. What I'm telling here is the curiosity for him to define the diameter of the planet. It did not stop him to travel so far and wait for so many days, and he spent his life at different locations and unknown places, and but still he could make it, and he's the first person to define the diameter of the planet. Okay. And now you know these people, right? Albert Einstein, Sir Isaac Newton, Christopher Columbus, all are great people. But here, why I put all these people pictures here is there is something new that we should know about it. For example, who is Christopher Columbus? Can anybody tell?
He was a sailor, sir.
Sailor. Okay. What he did? What he did?
He wanted to find India, but by accident discovered the Americas.
Very good. Very good. So here I am going to tell you. You can note his period, time period, 1451 to 1506. Right. Now, can anybody tell me, Sir Isaac Newton, what is his greatness?
Sir, that seven that spectrum. After that, the equations of motion, laws of motion, and after
Okay.
that some of the gravitation laws also he made, etc. Sir.
Okay. Very good. Can you tell one famous laws that he defined?
Gravity, law of gravity and law of motion.
Okay. Laws of motion. Anybody?
Yes, sir, laws of
First,
motion.
So
So the
famous one, Newton's third law. Anybody? Newton's third law. Anybody can tell?
B square is equals to U square plus 2as.
Every action will have a equal and opposite reaction.
Opposite reaction having an equal and
Very good.
opposite reaction.
Very
every
good.
action
Very good.
has its
So very good.
reaction.
Yeah. So every action has equal and opposite reaction. Now you see, I want to bring one point here. Christopher Columbus is a great thinker. Those times there were no gadgets much. He wanted to reach India, but he reached America by sailing. Now, how boat works? Newton's third law, every action, right? So now here, what I want to tell you is, though he is a great thinker, he could not think the law which is proposed by Newton after centuries, isn't it? So what I'm telling here is some great thinkers, whatever they aim for, their focus will be on that. Okay. So in the process of achieving that goal, he will actually discover so many things, but they will not be in a position to observe that. So here, both are great people, both are great thinkers, but in that process, some great thing we miss, but those things will be experienced. So here, the time period, if you see, some certain things were missed, but the thing is, both are great and great thinkers. And Albert Einstein. Okay, there are so many things to discuss, but here, what I want to tell you is I wanted to present you how great these people are. Okay, when I present those people, let us see our Aryabhatta, who invented zero.
Zero.
Very good. Okay.
Sir,
Yes, please.
along with the invention of zero, he also said that solar and lunar eclipses were caused by the moon and not moon.
Very good. Yes. So there are great things actually to discover and to find out. Ultimately, it requires our curiosity or jigyasa to do that. Okay. So now answer this simple question, which is on your screen. Can anybody answer what is the answer for this equation? Tell me.
Sir, zero, sir.
200.
Very good.
Zero.
Zero. Very good. Very good. Now most of you got zero.
Zero.
Answer is zero, marks 100. Okay. Now you tell me, how did you do the calculation?
So first is 99, and then sir, the 1 minus 100 is minus 99. So 99 plus
Minus 99.
Okay. So you did plus
Zero.
99 minus 99. Okay.
yes, sir.
Anybody else did other way? Any other way? Any other way? Okay. Apart
Yes,
from
sir.
plus. Yeah. Tell me.
Okay, so before the first term, 100 minus 1, there are dots, which means that it is probably a very lengthy equation. So you can safely assume the answer might be infinity.
Okay.
What is before it?
Okay. Okay. So here my point is, uh, yes. So we got the answer. Most of you, all of you said zero. Very good. So the thing is here, some people have done plus 99 minus 99. What I'm telling now is plus 100 minus 100 cancels, plus minus 1 plus 1 cancels. So how many of you thought like this? So that also reaches to zero, right?
Yes, sir.
So, so what I'm saying here is now thinking. So here I did not do any calculation. What is 100 minus 1? If I put, for example, 77 minus 23 or plus 23 minus 77, then you would have taken some paper. If I put some big numbers also, if I put big numbers in this equation, definitely you would have taken pen paper kind of thing, for example. But what I'm saying is the logic. Plus 100 minus 100 cancels. Minus 1 plus 1 cancels me. You need not do any calculation there, basically. By reading image, you can do that, right? So what I'm saying here is little bit different thinking will reduce our efforts in achieving the same thing. Okay. So that's what I'm saying. Let us think little bit laterally or being smart, then we will be ahead of our own crowd. So now how an airplane flies. That actually I did not explain much for you, but I gave the glimpses. You can think about it later. You need not answer now here. Now you can answer this question. How does a detergent remove stains?
So,
Anybody?
so
Yes.
a detergent is in fact a complex molecule which has two ends. Just think of
Okay.
it like two people holding hands. One end is hydrophobic, which means it
Okay.
does not like water, and the
Okay.
other end is hydrophilic, means it
Okay.
loves. So what happens is most of the stains are probably like grease, oil based, right? Having hydrophobic end. comes and attaches itself to that and slowly lifts it off. Lifts it off.
Very good,
Then
very good. So Soumya was raising hand. Soumya, would you like to say something? Okay. So what you said is exactly correct. So it's actually the chemical reaction. So why did I put this question? तो मैंने एक क्वेश्चन इसलिए रखा इधर क्योंकि ये हमारे डे टू डे लाइफ में जो हम करते हैं उस पे भी एक्चुअली साइंस रहते हैं तो हमें एक बार वी हैव टू जस्ट फोकस ऑन दैट, एक बार ध्यान देना चाहिए ताकि उसके साइंस को भी हम समझ सकें. ठीक है. So next question is, this is interesting. Have you ever calculated your vehicle speed? Anybody? कभी vehicle में जाते हुए उसका speed को calculate किया क्या?
Yes, sir. By keeping an eye on the odometer and measuring the distance, measuring the time it had traveled.
Okay, so you will see the odometer and you will see the time. Anybody else did it? If you are sitting in a bus, for example, middle of the bus you are sitting, how can you calculate the speed?
so speed is equal to distance covered in given time. We have to just know the distance. Suppose the distance between Udupi and Bangalore is 30 kilometers. The bus
Okay.
travels distance in about 10-15 minutes max. Means in
Okay.
10-15. Okay. So that means at least the speed must be somewhat that close.
Okay, good. That means you are seeing the milestones through the window and you are checking the time and you are finding out the speed. So how was the journey for you when you do all these exercise compared to when you are not doing all this? See, Raj is actually smart. He was using app, it seems. Okay. Anyway, so what I'm saying is, these kind of activities will make you active and you will enjoy the journey apart from improving your ability to think. Okay. Yeah. And now, answer to the question: why the things are visible to the eye?
Because sir, everything reflect their own light, so eye catches that light.
Okay. It is,
It is very
emits, reflects.
yeah. It is a very complex theory. No one is able to give a suitable theory until now, but the most accepted one is every single thing absorbs all seven colors of the light, but gives out a specific color. For example, a green leaf appears green because it absorbs all colors except green.
Okay. Very good, very good. So Rajveer also tells that light reflects. Light gets reflected by object. That's how we will see the objects. And as you said, wavelength, basically the wavelength which defines the colors. Okay. So now this also you can just go through that. But why I ask this question is basically the day-to-day life. Whatever you are seeing, you should give it a thought. Okay. So daily आप जो देखते हैं उसको भी एक मतलब एक नजर से देखना ताकि उसके बारे में भी कुछ नॉलेज आ जाए. ठीक है. तो इसलिए मैंने पूछा है जो भी मतलब हमारे आंख को क्यों दिखते हैं हमें कि कुछ उधर कुछ चीजें हैं. ठीक है. So now let us come back to the technical content. Okay. So there are some novel technologies in aerospace as I think Arya raised the thing that twin engine kind of thing. I just put the picture here for AMCA. So the latest technologies in this one that we are to develop is stealth technologies, endothermic fuels, smart materials, and advanced control systems. Stealth technology is basically to avoid visibility. I mean, we should be invisible. मतलब हमारे enemies को हम नहीं दिखने चाहिए. तो इसलिए हम ये स्टेल्थ टेक्नोलॉजी को यूज करते हैं. तो ये स्टेल्थ टेक्निक्स कैसे काम करेगा मैं अगले स्लाइड में मैं बताता हूँ. ठीक है. वेरी गुड. राजवीर इज टेलिंग दैट radar cannot detect. तो स्टेल्थ बेसिकली क्या होता है ना, ये रैडर जो भी ऑब्जेक्ट फ्लाई करते हैं इन एटमॉस्फेयर, रैडर विल सेंड द सिग्नल एंड इट विल सेंस द सिग्नल. तो अभी ऐसे स्टेल्थ टेक्नोलॉजी की वजह से रैडर सिग्नल सेम सोर्स को रिफ्लेक्ट नहीं करती है. तो ऐसे टेक्नोलॉजी स्टेल्थ टेक्नोलॉजी है. एंड एंडोथर्मिक फ्यूल, व्हाट इज दिस एंडोथर्मिक फ्यूल? यस.
So even stealth, not only radar, sometimes even heat cannot be detected in such materials, stealth materials.
Very good, very good. Even IR sensors also. What you are saying is IR sensors should not detect its heat signature, what we call. Okay, so that is also true for the stealth aircrafts. The radar should not read it, and IR sensors also should not read it. That's what. Then now, when it comes to endothermic fuels, I think you people have done one endothermic reaction in your house. Even your parents also might have done. Can anybody tell me, have you done it or not? Endothermic reaction in your house or sometime? Nobody? Now I will give you the example. Then you people will say, yes, I did. Okay, Nishant has said that during the reaction heat is absorbed. Very good. That is endothermic reaction. Now I am going to give the example. Have you people anytime drunk glucon D or glucose mixing in the water? Okay. So if you are not drunk that, if you are not drunk it, just try this exercise. Take some glucon D in a steel tumbler, okay, metal tumbler. Put it in some water and you mix that. You should realize how it will be, whether it is cold or hot. Okay, so that is actually nothing but endothermic reaction that you people do. So here, when it comes to aircrafts, the people are done endothermic fuels. In fact, I have published a paper also in this. So this is going to be the future fuels for an aircraft to cool the engines and engine components, and it preheats the fuel, because of which the combustion efficiency will increase, and it will help in longer duration, longer life of the components. Okay, this is going to be the future technologies for our aircrafts also. Smart materials, basically, you can read shape memory alloys kind of thing. These also will play a major role in future aircrafts and advanced control systems. Okay, so now one general question to you: where the fuel is stored in an aircraft?
Generally on the wings.
Wings.
I
Very
think
good. Now, okay, you can see the picture right side corner. I have shown you the how the fuel is stored in an aircraft. Okay, so basically the wings will act as a fuel tanks. Okay, so can anybody tell me what is ATC?
Air traffic control.
Very good. What it does? What it does?
It is like roads. They have like a traffic lights, right? Just like
Okay.
that.
sir,
It
it
is
controls the traffic, sir. When aeroplanes will take off and when it will fly, it detects when it is the takeoffing time, when it is the landing time, like this.
Very good. Very good. So ATC does that, communicating and guiding the pilots how to land, how to take off, and not only that, when an aircraft is flying in a cruise mode at certain high altitude, also the local ATC will be in touch with the pilot to know the condition in the aircraft. Okay, that means you may be thinking only in takeoff and landing only it is in touch. No, even in cruise mode also it will be in touch with the local ATC, and they'll be in touch and they will be communicating kind of thing. Okay, so ATC is for the communication and guiding the pilots for the landing and takeoff. And now the stealth, for the stealth, no, I have given the pictorial uh, view how that comes. Okay, you can see the radar signal, how it is hitting and how it get deflected rather than getting reflected to the same source. Okay, now this is end of our journey. Okay. So before going for the question and answers, now I want to ask you one question. Have you noticed this aircraft in throughout my presentation?
Yes,
As I
sir.
told, as I told in the beginning. Yeah.
Yes,
Can
sir.
you tell? Oh, can you tell me what did you notice about this aircraft?
Sir, it's a SARS aircraft.
Very good. Next, anything else
And
that?
it's a
Yeah.
70-seater aircraft. It,
Okay.
it is one of the first commercial aircraft produced in India.
Okay.
Sir,
It is made for small commercial flights, sir.
By whom?
By NL, National
Very good.
Aerospace Laboratories,
Very
Bangalore.
good. Okay. Proud to say it's my organization.
Yes, sir.
Anything else? Anything else that you have noticed?
the unique thing about this aircraft is that its propellers are behind, not in the front of the engine, sir.
Okay. Sneha, you can tell. Wanted to say something?
The plane first.
Okay.
Sir,
So, yeah. Tell me. Keep going. Keep on
what's
speaking.
Sir,
special about
sir, it has a turboprop engine,
Okay.
and its wings are at the below unusually than the other aircraft, which is at the above.
Okay. So now, again, one more time, I'm going to just change the slides quickly. You can just notice the aircraft and you can tell me. Okay. Now you can see the aircraft. Okay. 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 Now, can you notice anything about the aircraft?
conventionally, sir?
What
Most
is that?
airplanes have engines underneath, underneath the wings. This one has a right in the tail. The tail section, the tail element is one side up and where the elevators, the tail fins are replaced by those engines.
Vehicles
Okay.
able to fly by gaining support from the air.
Okay. ओके तो अभी इस सारे स्लाइड में हमारा प्रेजेंटेशन शुरू हुआ ये एक जर्नी है कि नहीं तो इस स्लाइड में हमारा एयरक्राफ्ट टेक ऑफ के लिए रेडी हो रहा है ठीक है अभी इस स्लाइड में टेक ऑफ कर रहा है ओके सो व्हेन आई केम टू द मिडिल ऑफ द प्रेजेंटेशन हमारा एयरक्राफ्ट क्रूइज मोड में है मतलब जर्नी जर्नी में बीच में है क्रूइज मोड ओके अभी ये मैनूवरिंग करना है टर्निंग के लिए मतलब हमारा जर्नी जो है लैंडिंग के लिए तैयार हो रहा है ठीक है अभी इधर लैंडिंग हो गया मतलब हमारा जो जर्नी है हमारा प्रेजेंटेशन जो है एंड पे आ गया और इधर जर्नी खत्म हो चुका है और हमने लैंड किया है ठीक है सो नाउ लेट अस मूव फर्दर queries that you have in your mind.
Sir, what is the difference between cruise and ballistic missiles?
Very good. The cruise is basically with the powered by an engine. Okay, it will move with certain velocity and it can be controlled. Okay, the ballistic missiles basically it will go to a certain altitude and it will be released. Okay, so there basically there will not be any power system to add thrust to that, but only thing is it can be controlled and it will go to the land. It's like a free fall kind of thing. So that is the difference between cruise and ballistic.
Sir,
Yes, please.
yeah, does India have a ICBM, intercontinental ballistic missiles?
You should tell me now. Did you find anywhere?
Yes, sir. India has BrahMos
It's a BrahMos Agni.
Agni 5.
Very good. Very good. Yeah. So now I'm stopping the sharing. Okay. You can have the video so that we can have better interaction. Yeah. Okay. Any more questions, please?
So I think students don't have any questions. They already asked you during the
Sir,
session. Is there any more questions, students?
sir, what makes an aircraft stealth?
Stealth, a very good question. See, basically, we discussed about the requirements for the stealth, right?
Yes,
Basically,
sir.
it should not be read by any radar or
Yes, sir.
any IR sensor kind of thing. Okay, so the basic difference between these, I mean, common aircraft and the stealth aircraft is the first thing is for the this stealth technologies. One is materials which
Yes,
can
sir.
absorb the radar signal. First thing, okay, it should not reflect the signal. Whatever the signal comes and hits its body, it should swallow it. It should not reflect it. That's one thing. By chance, if any signal hits its body, it should not reflect it back to the same source. It should give it like a deflection to other source. Okay. So that's where what happens is the radar will not receive the signal, but the signal will go into different direction. So in that case, what happens is it will not identify the object that it is there. Okay. So we have to misguide the radar. So for this purpose, there are different materials, different coatings, and different shapes that will help us in misguiding the radar. So that is the basic technology that we applied for the stealth.
Thank you, sir. Sir, is it possible to make a hybrid aircraft which can be stealth and also a fighter aircraft?
Exactly, some research is going on within India for the same purpose. Yes,
Okay, sir. Thank you, sir.
yes,
Sir,
yes.
Sir, if the radar is not detecting the stealth aircraft, then how can we the home radar will detect the aircraft, sir?
Very good. So their communication system will be different than the only radar signal. So that's how their through satellite communication they will have that. Our own people will be seeing that. But basically, this is for the fighter aircrafts, and for the short durations, they will do that.
Sir, and then you said that some details are also a factor for the making aircraft stealth. Then, sir, is that those metals available in our India?
Yes, yes, yes. See, research is going on. Some people have already succeeded in such technologies, and I think very soon you will hear in the general newspapers and media that some technology has been developed for the stealth applications. You will hear it probably within a couple of years.
sir,
Thank you, sir.
Yeah,
can I ask a question?
please.
Okay. Everyone here must have watched at least a Marvel Avengers movie where the the ship, in fact, goes invisible. Or some invisible
Miss
means they use retro reflection.
Miss
When the
Fernandez, wait a minute. Your voice is not clear. There is a lot of echo. Could you please repeat the question?
yeah, everyone here must have watched a James Bond movie or a Marvel movie. Where they
Okay,
use some kind of, like in James Bond, there is this car, an Aston Martin, which can go
okay.
invisible using retro reflection. When suppose the car is moving right, whatever is retro reflection tech, can that be
So
done on aircraft, sir?
yeah, so now in that movie you have seen, right? The guys they cannot see the car, but they will see the footprints of the car, and then when they fire it because of the bullets, that stealth property will go off, right?
Yeah, like that. Can that be done, sir? Like,
So see, that is actually beyond some imagination, I can say, because the basic stealth technologies development itself is taking years together, and that kind of thing. I'm not in a position to comment on that exactly whether are we going to do that for aircraft or not. Even cars also we could not do so far, right? Any Other queries, please.
So,
Sir,
students, do you have finished the queries or no? It is 3:15. This will be the last query, and then you can write to Mr. Venu on his email. Okay, I'm very happy actually with the way the class went today. It was total pin drop silence, and questions were asked, and so much attention and so much focus. I'm very happy. Please speak your last question and get it solved, and we will, we will all unmute our videos and we'll have a picture. So please, we have this as a last question. Please go ahead.
Sir, in helicopters, we can see that there is one propeller at the upper part. Means there is a fan-like structure at the upper part, and in the back also there is a fan. So, sir, what is the use of both of these fans?
Very good question, actually. It's a good observation. See, the top upper part, which is a bigger rotor, is actually main rotor for the lift and thrust purpose. The small rotor, which is fixed to the tail, is actually for the stabilization purpose. Stabilization, okay? So it is basically the
sir,
air. Tell me, Leslie.
yeah, about that. Earlier, they built helicopters with only one main twist, right? According to Newton's laws, if the helicopter keeps spinning, if the rotor spins in a clockwise direction, the whole helicopter spins along with it.
Yeah,
So,
that's what I'm saying. That's what I'm saying.
some person named Igor Sikorsky developed that ingenious system of placing another rotor that counteracts the spin.
Yes, exactly. See, that's what I'm saying. Some helicopters are having the tail rotor for the stabilization purpose. As you correctly observed, the main rotor motion will make the aircraft to rotate in the same direction. So the stabilizer rotor will help us in keeping the helicopter in a stable position. So some aircrafts are having a tail rotor, some aircrafts are having within same shaft counter rotating. That means one rotor will rotate in clockwise, another one will be in anti-clockwise to establish the stability. I think this kind of things you can see in Hollywood movies also. You can witness that. And if anybody is from Bangalore, they can visit Vishwesvaraya Museum. There is actually live example that you can stop the tail rotor and you can feel how it helps in stabilizing the helicopter.
Sir, why are there plans to go beyond Mark 3? So, you know that Blackbird, right? SR-71 Blackbird spy plane topped out
Yes.
at around the Mark 3. Why
Okay.
they attempt to go beyond Mark 3? Although there was a world record for 6.7 Mach 6.7 by human person. Why are they using airplanes in the Air Force like people
See,
do?
I will tell you. I will tell you this. Actually, very good observation.
I
See,
think this will be the last question from you because I think we have to end the talk sometime and you have your this email ID and please talk
What
to come to us
is the
later.
motion of the aeroplane?
I will answer this last question for the
Yeah,
supersonic vehicle.
please.
See, recently, whatever you have read in the newspaper for DRDO demonstrated the hypersonic technology, demonstrating vehicle in which there is a supersonic combustion happened, and NAL, my team, and I'm the part of it, demonstrated supersonic combustion and the technology given to DRDO, which they further developing it, and that has come in the newspaper. So your question, SR-71, that vehicle, actually that is designed for the Mark 3. But if you see NASA's programs, X series program, okay, they tried for Mark 10 also. But the thing is, there are a lot of technological issues for fuel usage, control system, the stability, and the materials. Because when the object flies at such kind of high velocities, the drag forces on the bodies are so high, because of which the thermal loads on the structure is very high, and because of which heat is generated, and the life of the object is restricted by this velocity and the drag forces. So that's why the research in the field is still going on for the decades.
Yeah, even
Right?
that was right. People aren't going driving planes. I mean, what I've seen is there was a record human
Why
flight.
don't you talk to him separately? Okay, we will end
Okay,
the
Yeah,
call.
Students, you can write to me. My email, I shared my email. You can
Yes.
write to me. I will be happy to answer you all your queries in a better way and better platform also. I can do
And
that.
you can, sit at length for it and you can discuss with him. Actually, it is a very interesting topic and today's session was the best session. Mr.
So
Venu,
what is
thank you so much for,
Sir,
please,
what is the motion of
for
aeroplane?
questions. Let's thank sir and, let you please take his email and, we can continue this, but there is a time limit. We have taken only 2 hours time and that is over, so we will not be able to continue it, okay, students? I'm very happy to see the enthusiasm, the curiosity, and the questions, and the lovely remarks that you all are asking him. And he's also very smiling and answering. It's really very nice. Thank you so much for coming on the stage and
Thank you.
talking to them. I think we will
Thank you
have
so much.
one more talk from you, Mr. Venu, in the coming months because I think students are really
Sir,
very
what is the motion of
happy and very
aeroplane?
nice questions they have asked you. So I think that with this, I thank you very much and I thank all the students. And we will now end and one by one, please leave the talk and end the talk and please move out. Okay,
Yeah,
thank you very much.
thank you, thank you so much. Thank you so much for allowing me to meet these wonderful children. Thank you so much.
Yeah, thanks. Bye bye.
Sir, the email, please.
Yeah, the email, you can take his email down. I'll put it in the chat box right away.
Sir, what is your email ID?
I'm sharing it for your
Yeah, you
convenience.
can share it.
I'm sharing it for your convenience in the screen. Okay, you can see in this slide, the bottom, you can see my email ID is there. Bottom, you can see venug@nel.res.in. Okay? Thank you so much.
Wait, no.
Okay, so can we just move out one by one? Can we just end the session and come leave the meeting? Please start leaving the meeting, and I'm also leaving the meeting now. I will end the meeting.
Yeah, thank you so much. I'm leaving. Thank you all.
Again.
Thank you all, and bye. Take care.